Binomial distributions are, when you're talking about binomial distributions with their probabilities and stuff like that, they're very simplistic to work with because there's really only a right or a wrong probability. There's a probability of success and a probability of failure. So you're really only dealing with two values. You're not dealing with the whole deck of cards, you're not dealing with the whole rolling die or anything like that. You're dealing with certain styles of questioning that can only lead you to two outcomes. We call those binomial experiments. They use it as binomial because the term binary, two outcomes, 0 and 1. A lot of coding is done in zeros and ones, bits and bytes. We're going to talk about what are called independent trials. How many times you're going to try to do something. We're looking for specific numbers of successes. It's something that I wrote on here for you guys that happens a lot of time. Do not overthink this. This really is very straightforward once you get down the lingo and how you utilize the calculator to make it work. And it all stems from mirroring the idea of that binomial expansion theorem. It was very, very easy to work with.
What should we write down for this part?
You really don't need to worry about any of this, Zach. To be honest with you, it's just an explanation of what it is. If you want to write it down, it's in your book. To be honest with you. What I want you to think of is if your probability of success is equal to 0.2, what's the probability of failure?
0.8.
That's all we need to worry about. That's about all the math you need to do in your head. So if success is 0.2, failure is 0.8. Okay?
I'm already overthinking this.
Yeah, I know you are.
Why is there no, like, no, you can have success, you can have failure, is there no, like,
Middle ground?
even middle ground?
Nope.
Yeah.
Success or failure. I'm looking at it as a very, very simple idea. And the way that we use this, and I put this in here about this experiment stuff, over the course of the next couple of days, hopefully tomorrow we'll do some of this binomial experimenting, where you're going to go yes or no to certain questions, and you'll be able to figure stuff out, and you'll be able to create your own model out of it. It's pretty easy to do. Okay? Let me show you an example. Here's our experiment. Put your heads on your desk, cover your eyes. I'm going to ask you a question, and you're going to say yes or no to it. And when I mean yes or no, I'll ask you to say yes, you'll raise your hand. I'll ask you to say no, you raise your hand. Okay, you can only say yes or no. You can't say both, and you cannot skip. Okay, so 6, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have 25 in here. Okay, cool. Here's the question. If you believe in UFOs, that they exist, raise your hand. If, you can put your arms down. If you believe that UFOs do not exist, raise your hand. Okay. When I said that everybody needs to vote, everybody needs to vote. If you did not vote already and believe that UFOs may exist, raise your hand. Jenna, you're supposed to vote.
I did!
I'm joking with you. If you don't believe, raise your hand. Thank you.
Okay, shut up.
Still missing somebody, but whatever. I'm just going to move it around and zip this out. Because I'm going to count it wrong. Whatever. So in this class, we wound up with this. You can look up now. Thank you for asking. Otherwise, you're going to start snoring. Yeah, don't fall out of me. 9 of you said yes. 16 of you said no. There's 25 in here.
What's your vote?
Well, I'm just asking the question, doesn't matter what I think.
Well, that's, well, if
Now-
you square root, then that's like 4/5, isn't it? What did you say?
Can't reduce fractions with square roots.
Well, if you're talking, you're not reducing, you're simplifying, but you could also, if you're checking the areas versus their sides, yes, you can.
Isn't it synonymous?
If you're talking about similar triangles, similar figures, you
But
can.
I'm trying to say that like 1/4 is not the same as 1/4.
Yes, I know. I know where you were going with it, but if you can take the square root of a fraction and just show the similarity of for similar figures.
Okay, I'm just.
Oh,
Zach-
you just got
No, Zach
told.
said you take the square root. That doesn't make any sense.
Anywho, what's 9 divided by 25?
A number.
Decimal.
0.36.
0.36.
Thank you.
So the probability of success was 0.36, which I'm guessing the probability of failure was 0.64. Now here's something that's pretty crazy. I know you guys are going to...
UFOs exist?
UFOs may or may not exist, I don't remember. We had, what was it? 40, what's the number?
Nuts.
Because I'm going to tally it up from the other classes, I just forgot the number.
We're gonna watch the other classes' videos.
No?
He's just going to run into their smart.
I believe that there are aliens out there, but I don't think they're
I
care
mean,
about
UFO stands for unidentified flying object, but does not mean alien.
You tell him.
Oh, she's proven us
They
all.
exist, they're a thing. It doesn't have to mean aliens.
I believe in all flying objects to be identified. It's my religion.
That's a fake religion.
No.
Anyway, as of right now, I use this question because I'm going to show you some data set here and show you how it mirrors kind of what the other classes were doing once the other thing loads out.
I'm a UF Catholic. Unidentified flying.
Wasn't it? It was 5 out of 10. And
10
then,
kids in another class.
okay, so it was 15 out of, yeah, it was 15 out of 40, and then 25 out of 40, if I believe.
Taking a peek into another class is learning. It's totally.
Yeah, so the other class, so far we had this tallied out as the yes from earlier. So our yes and no votes from earlier in the day were 15 out of 40 were saying yes. So I'm going to add your tally in. So we're at, what is that, plus the 9. So that's 24 plus 25. So it's 65 total. So 24 out of 65 of you guys, according to the 3 sections, believed in UFOs. Therefore, what was it? Therefore, 65, and then would have been what, 41 out of the 65 didn't believe? So this is your believe, and this is your didn't believe. And this is pretty cool because the book example,
Let's hear it.
Oh, here we go.
it's 0.37. I'm not kidding you. It's 0.37.
It's
According to a survey taken in the USA Today, about 37% of adults believe in UFOs.
It's a zero mind game created by the
But-
aliens from the UFOs.
But still, it's, what's crazy is that it actually, I know it's a small sample size, it's 65 people, but it actually mirrored out what the book said it was going to do. I thought it was pretty crazy that it happened. So,
Yeah,
well,
UFOs does not automatically mean aliens.
you're right. It's the other classes. The first class was at like 40%. The second class was at 37.5%. Yours brought the percentage down a little bit more, so it averaged out between 3 sections at 37% of people believe in UFOs. Now, what we're able to do here with this data set is we know that we can create the binomial probability via that data set. We said that there was a 37%, I'm going to use decimals, 0.37 success and therefore a 0.63 failure
You write that-
in believing in this.
Who
Okay?
failed though? What-
Well, what I'm looking at is people said yes, people said no. So
All of you said, who said no are failures.
we'll say,
Long story short.
we'll say yes and no then, okay, for right now. All right, we'll say yes and no. So what happens here is that we have a sample size of the whole experiment that I did through 3 sections of 65, was it 60?
65.
65 students total, okay? What I'm gonna do is I'm gonna take a smaller sample, a subset of that group, these 6 people, okay? Now, the number of people I'm looking at now to check the probability that 2 of them believe in UFOs. I'm gonna look at 6 people and trials. I'm trying 6 times these 6 people. My N value will be 6. And I want K, I want 2 successes. I want 2 people to believe in UFOs. So what I'm doing here is that I'm going to take these 6 people, going to survey them. Survey says, do you believe in UFOs? Do you believe in UFOs?
Yes.
Do you believe in UFOs? Do you believe in UFOs? Do you believe in UFOs? Do you believe? Success! What was the probability that that was going to happen? Well, we take the binomial expansion theorem-ish, and we fill in the blanks. Our number of trials, here's what it looks like. We want the probability that this K value is going to equal 2. I want 2 successes. How many people did I sample? My number of trials, the number of times I've asked, was 6. So it's 6, choose 2. What is our probability of success? Our probability of success, what we want, our probability of our yes, if you will, was what? The probability part was the 0.37. That was what we found out. How many people did we, according to all of our data, 37% of you guys believed in UFOs. So our yes vote was 0.37. How many successes am I looking for? 2. What's 1 minus 0.37? So that's why I wrote that out right away, because you're always going to use that. And now remember the rule when you did binomial. If the first exponent was 2, what would the last exponent have to be if it has to add the 6? 4. Remember the trick when we did that a week or so ago? This exponent and this exponent matched. And then we also noticed that the top 2 exponents added up to be the first one.
Yes.
It still works the same with these. Okay? So all we have to do now is really put this in your
Do we have
calculator.
to subtract n minus k?
Nope. You did that. What's 6 minus 2?
Oh, okay.
Okay? I'm showing it as an easier version of what they write it out as, because you know what you're doing. How many trials? I had 6. How many successes do I want? 2. What's the probability? 0.37. What's the complement? 0.63. Squared, 4. Yes, ma'am.
Just to make sure that I plug that in, people who do.
Yes, that's what I'm looking at. What do we get? So when you type all this in the calculator, the probability of having exactly 2 people equals 0.32. So we had a 32% chance of sampling 6 people, and I'll get 2 yeses, according to my data.
What does that help us in the real?
We're getting there. We're getting there. A lot of it has to deal with sampling bias, sampling tendency. If you know the probability of a study like this that we did, and all of a sudden you go to a classroom and everybody believes in UFOs, well, does that data seem kind of out of whack?
Yeah. What if it's a class on UFOs?
Then you might want to rechange your sampling, who you're changing. You're looking at, now you're starting to get
Change your
into,
sample, who you're changing.
well, all right, let me rephrase that. You're going to look at how you're going to randomly sample.
Different demographic.
Correct. You're going to change your study. It's all about experiment and how it becomes a valid experiment versus an invalid biased experiment. You're not going to go to a baseball game and ask white people, do you like baseball?
Yeah.
You're not going to go to Bacon Fest and ask them if they're vegetarian.
Yes.
No offense. That's a good analogy though, right?
Is it an analogy or is it a joke?
No, it's an analogy. Because you're not going to go and ask a bunch of people at a Bacon Fest if they're a vegetarian.
Analogy is comparing things. No, wait, that's a similar.
You're not going to ask that question.
There are some people, you never know.
I agree with you, but you're probably not going to get a valid sample size. Yes, ma'am?
I mean,
Is there actually a bacon fest?
Yes.
Where is it?
The most recent one was in Chicago not too long ago.
unless you're looking for a number of vegetarians and bacon.
Yes. I have made, just recently, I made candied maple bacon.
That's really good.
And we dipped it in chocolate fondue.
Why didn't you? They have
It was pretty good.
Last day of school, you show up.
Yeah. It was candied maple bacon so I basically caramelized bacon. So I turned it, it was, and we salted just a little bit, and then we dipped it in some fondue.
Tyler made bacon waffles.
It's just instant heart attack, but whatever. So here's what you can do with this. I actually threw this in the notes about saying, hey, let's look at this sample out of the book, because you guys just did the randomness of it and worked out the numbers to be the same. So what will happen here is you're going to get these very simple scenarios. Probably not so much today. Today I think I'm going to focus more on just working with the formula and showing how everything kind of puts together. When we did this one a second ago, we knew that we were looking for 2 successes. We were sampling 6 people. Our p-value, the probability of what we were looking for, was 37% according to our original data. And that's what we did. Then we also wrote down what was 1 minus p. Well, we wrote that as 0.63. So you're doing is you're taking these values and you're just substituting in. It's really, really fast. Okay? The other thing that we're going to work on with this stuff is that we're going to create histograms. Bar charts. Bar graphs.
Oh.
The calculator does it. It just takes a little bit of time to walk through it. Okay? So what I want to do is I want to go through, we had 6 trials here for the 6 people. I'm going to list out all the probabilities of nobody believing in UFOs, 1, 2, 3, 4, 5, and then all 6 of them believing in UFOs. If I'm sampling 6 people, I have 7 things to look up, 0 through 6. We okay on that?
Yeah.
So let's do this.
Zero people just means
I'm going to take, it's not 0 people, it's like I want nobody to believe in UFO. 1 person to believe in it. What's the probability that none of them believe in UFOs? What's the probability that 1 of them believes in it? Probably 2, 3, 4, 5, and 6, all like that. What this type of binomial experiment allows you to be able to do is that event map, is that you can take the idea of multiple guess tests, multiple choice, excuse me. What's the probability of success on a 4, like A, B, C, D, multiple choice?
1 in 4.
0.25. So your probability of success in a multiple choice test is 0.25. Probability of failure is 0.75.
Wow.
Well, if you've got 10
Put
questions,
that in perspective.
if you've got 10 questions on it, what's the probability you can get all 8 right just by randomly guessing? That's the kind of stuff you can do with this.
I'd rather spend all my time figuring
No.
out on the final actually.
It's a little bit different. Okay, it's a little bit different. So what I want you to do is this. I want you to create an L1, L2 table in your calculator real quick. And I want to type in my L1. I'm going to put in 0s through 6. That's going to end up being our X column in our grid. And then our L2, you can type these in directly.
Please don't make us do a regression or anything.
No, there's no regression in this one, Clay. It's just you're typing the formula in. It's just a little tedious stuff to put them in. So you're doing your 6 choose 0, 0.37 to the 0, 0.63 to the 6, 6 choose 1, and so on and so on. take a minute and put those in. I want to walk you through how to create the histogram because there's a couple things you have to learn how to do on the calculator. Okay? So take a minute and do that real fast.
I think the combination of like 6 choose 0 the same as 6 choose 6.
Yeah.
So can't you just type in the same number? Or do you have to do the whole process?
You gotta go through the whole process because check out your other two parts. It's 0.37 to the 0, it's 0.63 to the 6. 0.37 to the 6.
Oh, because I got you.
So at this point, hopefully you get the kind of the idea of it. You've got two sets of data. What I want you to do first of all is hit y equals and hit clear in case you have an equation in it. Because remember, that's just going to be all sorts of bad. Next we're going to do is change our window. We need to change our window. If you go back and forth with your table, we know that our x values go between 0 and 6. Are we okay with that?
Yeah.
I'm going to make my x minimum 0, my x maximum 6, just so there's a little bit of space. If you want to make it -1 to 7, that's fine too. That way you have space on it. Actually, we'll do that, -1.
And the y minimum, y maximum, 0 to 1.
What I'm doing here with mine is that I'm putting that -0.1, and I'm putting my maximum at 0.5 because, bless you, nothing gets bigger than 0.33 if I'm not mistaken. Okay? It's just going to be, give it a little bit better of a window to see the data a little bit clearer. If you put it at 1, it's not a big deal. Yes, Reed?
Can you read what you have from all that?
I have -1.7. My x scale, it's going by ones. My y minimum for this one, I'm putting at -0.1. That way I can see kind of what's going on. It just makes the window a little bit cleaner. My y maximum is at 0.5 because nothing's bigger than 0.34 really. And then my scale for how far it's going, how fast it's going up and down, I put them at 0.1. You'll learn to play around with your window a little bit here to try to see things. So now we need to turn the stat plot on. So we hit second, y equals, and you want to turn the first stat plot on. So you click enter. Hopefully it's selected on, if not just move the cursor so it's on. Move down 1 and go all the way over to the right and hit enter on the bar chart. Okay? Now, your guys probably shows underneath where it says frequency, it probably says 1.
Yep.
You need to change that. Because think about bar graphs. Bar graphs were originally frequency tables. You know, if you're between the ages of 10 and 20, there's 15 of you in a room.
Wait, what do we use?
12 or 21 to 30, there's 12 of you in a room. So the frequency would be on this. But we're going to change that. We're going to change that frequency instead of being by like ones. I want you to change it to L2. How you do that is just move your cursor there and hit second, number 2, and it should change it automatically to L2. Okay? Ooh. And now hit graph, and you should get a bar chart.
Looks like it's flipping you off.
Yeah, it's got 6 fingers.
So then,
Dang it, Zach.
that is a histogram. The reason why I wanted to make sure you guys saw how to create histograms is because eventually, or maybe so today, oops, I want you guys to look at this question via your calculator. What is the probability, according to your data set, of getting at most 2 people out of the sample of 6 here that believes in UFOs? At most 2. Well, what probabilities am I looking at?
0, 1,
I'm looking at, because this was what, 0, 1, 2, 3. Okay. I'm looking at most 2, so I'm looking at all of these probabilities. So in my table, all I have to do is just look at my y values and add them together. Those 3. Does that make sense? What do you want? What? Yeah, you gotta be careful when you're typing. So if I go back to my stat, go back to my edit, look at my list, I'm going to add at most 2. I'm going to add these 3 values together, 0, 1, and 2. And that would give me the probability of at most 2 people believing in UFOs out of that 6 in the row.
Do we add every single digit there, just like the first three or third decimal?
Yes, you can go first three if you want. It's going to be negligible within the variance there. So I don't think that big of a deal at that point. Okay. What this is going to allow us to be able to do, like I said earlier, is that eventually we're going to switch gears into turning these bar graphs, these histograms, into curves. And as we turn them into curves, a lot of these histograms are going to norm themselves. Okay? And if you think about it, just theoretically, if you flip a coin 10 times, how many times should heads be? 5. This is 50% of the time, right? How many times theoretically should it come up, or let's see, let me rephrase this. How many times do you think would it show up 8 times?
What is the probability
Yeah.
that it'll show up 8 times?
Wouldn't it be the same as 2?
4.
Yeah,
In theory, it should be
Yeah.
8 too, because they're normed.
yeah.
What this happens is, you guys ever hear of something called a normal curve?
No.
Normal curve distribution, and this is 12.7, we kind of use the limit of this to get there. Normal curve distribution basically states that half of all of your data occurs to the left of the mean, and the other half occurs to the right of the mean. Also, they throw in here something called standard deviation. What that means is a measure to the average. It basically says 68% of all data will be within 68% of all data will be within one standard deviation of the mean, if you will. 98% will be within 2, and so on. It's very easy to work with. Yes, sir.
So you made that curve, is that kind of like the grade curve and stuff like that?
Yeah, a lot of it is.
So
A
do you
lot
have-
of it's grade
if you-
distribution.
If you were like curve a test, do you have to plug in every single thing?
It depends on what I'm looking for, okay? A lot of times I'm looking at raw score instead of percentage. I know that if I'm tallying up 60 tests and I have 15 of them that are at 45, something happened at that value that means that's a standardized grade out. And I move the curve I adjust to that. But I know what you're talking
I have
about.
another question. So the curve goes up and then it goes down.
Uh-huh.
So if a bunch of people get a lot of 50s
Uh-huh.
and fail, the curve gets higher at the 50 area?
It skews.
Does
Yep.
that mean a person with 100 gets a low grade because the curve's gone down?
No, because it norms itself to the way the curve works is that it would help the people on the back end, and it's not going to hurt the person at the front end. Okay? The way that numbers, because you can mess with numbers. I mean, 80% of statistics are made up on the spot and they're half right.
It's like Ron Burgundy.
I just made a great analogy.
What's that?
In SpongeBob. He's a square, you know? And then there's this episode when he wants to be normal. And as he's progressively getting more, he rounds out. And then he turns into not a square, but an actual thing.
Man. What I want you guys to do tonight, what I want you to do tonight is just a few of these to start with. I'm looking at the idea of coins and What's that? I can't hear you. No, we're not going to do that on Friday. I want to do 10 and 11, and then 22 and 23. I want to do 10 and 11, 22 and 23. I know it's just 4. Don't freak out thinking it's going to take you an hour and a half. It's not. It shouldn't take you 10 minutes. What these first two questions are talking about is you're flipping a coin 20 times. What's the probability that you're going to get 10 of them to be heads? What's the probability that 11 of them are going to be heads? Well, what's the success probability of heads? 50. So in this case, your p-value would be 0.5. Oops. And what would the 1 minus p-value be? 0.5. In this one, they're talking about multiple choice tests. So the probability of getting it right is what?
Percentage.
3.25, and then what's the 1 minus? That's your little hint. It's very, very, very easy to work with. We'll build more on this tomorrow.